All right, thanks for joining. Um, for those who have joined, I'm starting a little late today because I was trying to set up my computer and oh, sorry, there was an echo. um, yeah, so I was trying to set up my computer and there were some issues. Um, so I had to kind of reset and do a bunch of things. But anyways, I'll be online. Um, Yeah. Okay. So, well, today I'm trying to understand more about Kubernetes and CPU resource usage, really. Um, Mostly exploring it through with Rust. I um, so I'm kind of building cube a like a cloud hosting kind of platform where um people can deploy their code. Not necessarily deploy their code. It's kind of is still some specific code, right? And so obviously I'm well not obviously. I mean obviously I'm using Kubernetes, but like it's not obvious. I'm using Kubernetes and so yeah, I think this diagram is kind of easy. So it's kind of like the standard flow where people publish stuff through GitHub, right? And then there's a build queue that handles all this. This infrastructure is kind of like Kubernetes. I think for me, it's kind of zooming in on here where people can have instances of their projects running. There's more to this, but what they can run is limited. However, so for each of these instances, for each of these like running instances, I'm giving them. I want to give them some particular CPU resource, right? It's like I want to specify CPU limits for these instances, right? And so, well, that's going well. However, there was a question. So, when specifying CPU limits with Kubernetes, right? You specify one CPU unit, which can be equivalent to a physical CPU core or one virtual core, depending on whether the node is a physical host or a virtual machine I'm running inside a physical machine, right? And so um, I'm specifically giving each of these instances less than one virtual core, right? And I ideally it only hosts like Node.js projects, right? But I was just curious that so if I specify zero point 0.5, right? Um, and let's say we are using something like maybe C++ plus plus or like Go, where like you can multi-thread stuff and try and use as many CPU cores as possible, right? That what um how will those kind of workloads, how will they kind of see? So for example, um I put together this so I put together this question, and this is what I want to kind of run through to this evening to try and figure out if I can answer this question. So basically, I'm saying how many CPUs. Okay, so first thing, yeah, I plan to use Rust because I'm kind of like refreshing on Rust, right? And so first thing I want to know is like, okay, in Rust, right? How do you know how many CPUs are available on the running machine? And then the next thing I want to try and figure out is how does this show up in a Kubernetes workload container? So like if I run this on my host machine, what does it show? Then if I deploy it to like a Kubernetes node, does it with less than one vCPU, with multiple vCPU, does it what does it show there as well? And then yeah, then this is also another question which I mean, from previous like experience, I've been able to run like multiple threaded stuff, I think. Um, but yeah, so this is kind of looking into that as well. Obviously, I'm sure there are articles online around like how the OCPU resource utilization works. I would look into that as well. Anyways, so yeah, so that's what I want to quickly run through tonight. Yeah, like on this call, right? So the first question is really this, right? Um, I don't know if you were on my previous coding calls. You probably know I tend to use Chat GPT. However, hmm, yeah, I didn't really prepare. I didn't really I didn't prepare for ChatGPT, so we just use Google for now. Um, um, but then I'm actually interested in knowing how this would work. So I would try and do something like, does this work here? Okay, I need to log in. Hmm. Yeah, so I'm going to use their playground because my current GPT chats yeah, it's not ready for the internet. So I'm just going to switch this to try and do GPT-4, and let me just say um you are a cloud DevOps um I guess expert. By the way, if you've not used chat, I mean, most people use the chat interface. This is kind of like the chat interface, but it's kind of how the API is modeled if you want to kind of set up the stuff. So you specify the system. Basically, system primitives are like requirements that you tell the system behind the scene so that it kind of moderates what your users will say, right? Um, you're a cloud DevOps expert with um answering questions on the internet. Restrict your answers to only Kubernetes, right? And so this is kind of what you pass to the machine. What's is it machine? The Yeah, the bot, right? And this is the chat. So this is kind of like what your users will interact with, which is what we do normally in chat, right? And so here I'm just going to ask my question straight up, right? Which is this? And let me see. Oops, sorry. I'm supposed to submit, right? Okay. As a Kubernetes expert, that's interesting actually. If you want to check the available oh wait, what? Oh yeah, yeah, yeah. I think I jumped the gun here. I I jumped the gun actually because I think this is yeah. Anyways, this is not what I want to ask. So I'm gonna get rid of this for now. And do you hold on, let me clear this. Let me re-ask the question again. Okay, so it says you can use the num CPU create to get the number of available CPUs on the current system. Here's how to do that. Okay, it's writing the full cargo project for this. So mm-hmm, mm-hmm. Okay, so it returns number of CPUs. Number of CPUs returns number of logical CPUs, which might include hyperthreading and similar technology. Okay. If you want the number of physical CPUs, use this instead. So it requires this stuff. Okay, so this is saying I should use an external crate, which I think is good. But let me ask, what if I don't want to use an external crate, right? Because I'm interested in on knowing. I don't. I think Rust should have something in here. So let's see. Wait, what? To get the number of available. Um, oops. Hmm. Oh yeah, this gets complicated because yeah, different operating systems have different. Hmm. different operating systems have different ways of like basically querying the operating system and figuring out what the CPU like how many like available cores are there and all that. Hmm. Okay, so I think I'll stop this. Yeah, I'm going to stop this. This doesn't look yeah, why isn't it scrolling? I think I broke it. Anyways, by the way, I'm using the GPT-4 model, um, which I should be better, um, arguably. Anyways, so I'm just going to use the crate, right? So it says to add this crate to my cargo.toml file. So I think I will just do that. I think cargo had, I think it's num CPUs, right? Num underscore CPUs. Yeah, so yeah, I had to reinstall Rust. I'm sorry, cargo and Rust up and all that stuff. So yeah, this will take a few minutes actually. Um a few seconds, maybe. Or not. Anyways, that should be faster. Then the next thing we need to do is so this I guess in Rust this is kind of old already because you don't need to use extern crate anymore. I mean you don't need to specify extern crate anymore. I'm surprised GPT-4 is still recommending this, but you don't. It was I think it was like an old Rust version where you needed to specify this value. So okay, cargo hard has been done. Um, let me push this down. Let me check my cargo.toml file. Yeah, so it's here. Um, I'm just going to copy the code here. Then okay, so I don't need this anymore. I think what I need to do instead is say use num CPUs, and this should work, right? So I'm just going to cargo run this. Let's see what that says. All right. All right, so this says I have 10 CPUs. I guess technically I do have 10 CPUs. Um yes, I think I do have 10 CPUs. How do you check this? I'm on an M1 Mac, right? And so um, I mean, actually, I guess let me just ask how many CPU cores. So it's weird why I'm using Google, right? Because I okay, and I think an M1 was M1 came out like 3-4 years ago, so ChatGPT should know about it. But I'll just ask you how many cores does an M1 have? Yeah. Okay, so oh sorry, M1 Pro, right? Yeah, so it says M1 Max with 10 core CPUs and 32 GPUs. Okay, anyways, so yeah, I think that tracks. This says you have we have 10. Let me run that. Yeah, so it says number of CPUs is 10. Okay, cool. So I'm assuming this works, but let me try with number of CPUs and I think physical CPUs, right? Um, I mean, I could just do, oops, physical CPU count, right? And according to ChatGPT, what did it say? It said to get the physical count, we need get physical. So I'll just do this and say get physical, right? And I'm going to rerun that. Let's see. Oh yeah, I'm not. So this let's see. Okay, so it gives me the same value, which I think is fine, right? And I think that kind of answers my first question. Oops. Markdown shenanigans, right? And by the way, I'm kind of working on an article which will kind of be the outcome of all this, my research as well. But so then the next thing is, how does this show up in a Kubernetes workload container? Right. So here, the way I was thinking about around this was to um the way I was thinking around this was to run um I mean just containerize this guy, like create a Docker file for this Rust project, right? And then deploy it to I think the local Docker Kubernetes, and then so this same log, right? I will just check the logs for this, but then I'm going to vary the number of like CPU limits provided to it as well to see if that works, and then we'll kind of build the results from there. Uh, so I'll use ChatGPT as well for this because why not? Reset. How do you reset this? No, 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 no. Wait, what? Where's the reset? Da-da-da-dum. Yeah, I thought there was a reset somewhere. If there's no reset, I'll manually clear them. Clear, clear, clear. Right. Now I'm going to ask here. Um, I'll just say give me a Docker file for running a Rust I guess binary application. Let's be more specific. Um okay, yeah, just submit this. I think I really love this whole AI stuff. I should actually be using Copilot. Okay, I'll wait for it to write the code. But I should actually be using Copilot, and let me just add those extensions here as well. Can I? Um yeah, Copilot. I think it's the GitHub one. Then uh okay. Just- Okay. All right, that's installed. Um and then I'm thinking, so I can create my Docker file here. New file. Let's call this Docker file, right? Um just yeah. I mean, no, that wasn't what I needed to be installed. Anyways. And then we can go back to ChatGPT, and so it gave me this file. Um so I'm just going to copy the Docker file, right? Yeah, this didn't oops. Yeah, this didn't complete. So I think it's like the maximum token length. Oh yeah, I probably should increase this to maybe like 800. For those who haven't like programmed like any of I've not programmed on any of all this like AI stuff, right? These are some of the parameters that you use. I At least for my experiments, yeah, I would definitely do a series on this as well. But I experimented with the open source models, and one thing I noticed was if you increase the maximum length of like results that can be generated by these AI models, it tends to be rubbish. But then I was testing with like a relatively small data set, so of course it would have more rubbish. Anyways, so I'm just gonna try and say continue your answer for now. But then I'm going to copy the what I did, put it here, and it kind of makes sense. What's the latest version of Rust? I think it's in a Rust C, right? So 1.69. So I'm going to change this to 69. right? Um, so it says creating this working directory, copy this. Um, oh yeah, to run the build, remove. I mean, this is really nice. Like running the release build, remove the dummy this, copy the source file in, and rerun the build, then create a release, install all this stuff, then copy the final binary from the build stage. Yeah, so this would be a copy statement, which I'm going to pick up from here. So yeah, so continue your answer, kind of give me the final thing, which is good. And then you paste it here. I'm going to copy this as well. Right. I really okay. So yeah, this is going to be interesting because you need to have a you need to have a server running for this to work, right? Um. Anyway, so we are copying. Okay, so my binary name. Interesting. My binary name is what? This should be this long thing, right? Um. Okay, hold on. Let me just run the release build as well, right? And so I can confirm what the binary name is. The reason why I'm a little bit confused is because okay, yeah, I know there's usually some things with lowercase and uppercase. Anyways, this is the binary name, so I'm going to copy that name, replace all this. Actually, I can do this right. Right. Okay, so this starts the app. Fine. Now this expose, we don't need to expose a port, right? But then yeah, I think an easier way. Anyways, okay, yeah, it's fine. I was saying like you need to have like a running service with a bunch of stuff, right, for Kubernetes to pick this up. But I think I have another idea. Instead of running this as a deployment or something, I'll just run it as a job and I will try to inspect the logs from that job. So that way it just runs once and I still have access to all the other stuff. Right. And okay, so I guess I can try testing this locally first, right? And I think the easiest way to test this would be please tell me there's an easy way to just to click stuff. I don't want to write commands. Um this is supposed to be a fun, yeah, build image. Um, yeah, I guess I can call it this. Right. So this might do a bunch of pulling here and there. Um, Let me take a look at the charts to see. Um, okay. Yeah, okay, cool. Yeah, so yeah, this is just Docker build stuff. So I know I don't know. Rather, I don't know if you use ChatGPT in your well, basically, there are a lot of AI tools actually, not just ChatGPT. For example, I installed Copilot. I didn't try and use Copilot here though. All right, so press any key to close. Oh, is that a new feature? Okay, of course, because it's where's that one? I'll, uh, anyways, yeah. So I think it has been built now, right? Um It has been built. I'm clicking everywhere because I don't want to type stuff, right? Yeah, this. So I want to try and run. Yeah, I don't need ports. I don't need volume mounts. If I just run, okay, it's naming this great grider. I just want to see the logs. What does it say? Does it say 10? Wait, is it running? Oh, that was fast. Um, yeah, this is why you don't just copy chat GPT. So what's going on in the doc file? Oh, okay. Oh, yeah. Um, yeah, I think this should work, right? Because app, the entry point is app, right? I'm not specifying any command specifically, and it doesn't even matter if you specify any command, right? It should just run and show this. To execute the command, let me run. Yeah, and it's executable. So why isn't it working? Wait, what? You need to restart the process to have access to stats, inspect logs connected to hub. Yeah, there's I mean, this looks um okay. Let me see. If I try to, where's the name? I'm just gonna try running it here. What's that called? Docker run. Actually, hold on. Okay, Docker run. How do you? What's Docker run again? I think this. Um. Okay, hold on. I think I'm supposed to. Yeah, let me just do my test. Right. Hold on. Is it? I think it's name, right? Yeah. Okay, that's quite interesting because are we actually doing anything? That's super weird. Um, hold on. I mean, if I let's so I ran the build, right? So if I run target release this guy, right? Yeah, this works. I mean, this works here. And it's exiting with a status 0, which means, right? It's exiting with status 0, which means it ran successfully. Oh, hold on. Okay, hold on. Um oh, okay. I need to remove, let me pull this up. I need to remove my test, right? Cool. Um then I think there's a the app in RM. Weird. Yeah, so the RM is just to ensure it always cleans it up. That didn't work either. um okay, let me try something. If I how do you sleep? Um Actually, I don't know if Copilot has kicked in, but let me just no. Um no, that's not what I want. No, don't disable for us. Okay, you know what? Just sleep rust, right? I think it's tried sleep rust, yeah. Yeah, standard thread, blah blah blah. Yeah, sleep for 10 milliseconds. Okay, I'll just copy this because mm, right. And then I need right. Oh, now you know to do that. Okay, cool. Then I'm going to cargo build again, right? And then rerun. Okay, so it waits 10 seconds, right? Cool. So next thing I'm going to do is I'm going to try rebuilding this guy, right? Um, is that done? Okay, I think it's done. Right. So now that it's done, I'm going to Docker run it again. Okay, so um well, this is interesting. I guess it's because well, this is one of the reasons why they say Rust is quite fast. So I think it just ran so fast, and the pod died, or sorry, the container died. We're not in Kubernetes yet. The container died before the logs could have been collected, and so that's why it's empty. So I'm going to just try it from the Docker UI again, so it doesn't look like the UI was rubbish, right? Images, yeah, I need to run this. What were those? Okay, so here we can name it, right? So I'll just call this UI test. Alright. Yeah, so it works now and the logs are collected. Okay, cool. Yeah, I think this is useful. We tested this as well. Okay, I guess first interesting thing here is even though we're not running in Kubernetes, it says we have 5 CPUs. Okay, so this is interesting. Um, it says we have 5 CPUs, and I think I know why. It's most likely because you can, yes. So when starting Docker, you give it like a number of CPUs, so it doesn't use up all your memory. By the way, this is also an int to anyone where you feel like maybe your Docker, um, like running Docker on Mac, and Docker is slow, or you feel like you're running something in Docker and it's struggling, especially if you're using like Docker Compose and it's spinning up so many systems and stuff, right? You might want to give it some more CPU, right? And or like increase memory as well. And so because the virtual machine that Docker desktop spins, Docker on Mac actually spins up. Um, it was, I guess it was spawn. Actually, it was past tense of spawn. Anyways, um, so we can try enabling this here. Um, Apply and restart. Installation. Oh, interesting. Wait, I thought I had. Now it's asking for my password. Hmm, that's weird. What's my password? Right? Maybe. Anyways, so now I'm trying to run Kubernetes. I'm trying to deploy to a local instance of Kubernetes. Maybe I could probably just use DigitalOcean to spin up something as well. But yeah, so that's the first thing down. We seem to be reliably getting like available CPUs and physical CPUs, and they seem to match. But what now happens, because in Kubernetes, like pods and the whole API server, they're all different. So how do we do that? I think that's the question. All right. Okay, this is taking long. Um, I guess while this is going on, so we have the image file here. Yeah, I think this is one of the reasons why I don't. This is one of the reasons why I don't want to. Um, why I don't want to use like DigitalOcean or some external host, because it means I would need to publish the image. Yeah, that shouldn't be a problem. I mean, there's nothing secret here, so I can probably just publish to my public Docker registry. And I think that should work. Okay, so I think this has restarted. Um, right. Okay, manage personal clusters directly in Docker Desktop. Right, cool. So now, hmm, that's weird. Okay. All right. So we can go back to. Actually, we'll just use Google for this. I think one of the issues, or one of the issues with like most of this interactive chat stuff, is the fact that why don't they just print out the results at once? Um, I think there's some reason why in terms of how they generate and regenerate stuff. But then sometimes it can really be tiring waiting for the whole waiting for like the messages to come in. So I would prefer give me what you've generated first, right? If you are trying to reevaluate and do stuff, just tell me, like show me a loader beside, right? So like at least can start reading, right? And yeah. Anyways, so I remember there is something to set up Kubernetes on your local. So we'll just check that out, right? I think it's set up local Kubernetes cluster mark here. What's the name? What's the name? What's the name? No, 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 no. Yeah, Minikube. That's weird. Yeah, Minikube. So, yeah, I think this is what I'm looking for. Right. So Minikube is saying you will need two CPUs, two GPUs, blah blah blah. I mean, we clearly know I have more than two CPUs, right? Because we've been seeing 10. Um, yeah, okay. So this will start, then we can start interacting with Minikube. Cool. So I'm just going to get this. Uh, um, actually, I'm on right. I need stable. Actually, can yeah, I knew it was. Yeah, I think I knew it was a little bit easier to just do this. So I'm going to run Minikube to install. Where's my terminal? Yeah, I'm just going to. Oops. Let's move this here. Bro. Okay, I think I copied it, right? Yeah. I'm having to do all that stuff. I hope I don't have some permission issues. If you've joined so far, kind. Yeah, that was the what I was looking for. Thank you. It wasn't Minikube. Ah, I think it was like a four-letter word, like emmed, and some of all this weird stuff. Thank you, Bosunski. Because I think mini I kind was easier to set up than Minikube or the yeah. Hmm. Yeah, so exactly kind you can create clusters and all that stuff with it. So the last time I interacted with kind, I know it was I was trying to yeah, I was learning how to create custom resource definitions in custom resource definitions, basically custom resource handlers and all that stuff, right, in Kubernetes. And so I know kind was kind of easy to set up a replicated like local test environment before deploying to our production side of things. So the question is, how easy is it to install this now? Um, where's the installation? It just says you can install kind with Go. This will put kind in your env. Okay, and then to use kind, you also need to install Docker. Hold on. Yeah. Yeah. Hold on. Let me just see if Minikube works. So if I do Minikube because start, right? Yeah, because I think the benefits, I mean, right now I just need somewhere I can deploy stuff to, right? I know how many CPUs are existing on my virtual machine, which is five currently, right? And so now I just want to play around with, yeah, I want to play around with the resource, CPU resource limits and all that stuff and see how that works, right? Um, yeah, this is installing and downloading stuff. Thanks Bosunski for that. Okay, I guess while that's wait, no. I don't want. Why is it creating two CPUs Docker container? What? Um. mm, yeah. Okay. So I think it says it has been configured. So if I check here, yeah, Minikube is here now, and I think we can start using this to test things out. One question is this: preparing the fact that it's using two CPUs is what I want to change. But then at least I know it's two CPUs, so we can figure out what's going on there. Um, so I'm just going to create a job, right? I don't want to create this. I just want to create a job from like this image. But then actually let me test this out just to confirm that everything is working. Um, so let's say I create. So this creates the deployment and the service, right? Yes. Then we can confirm that the service is running, right? The easiest way to access this service is let me. Oh, really? Oh, interesting. So you can have Minikube actually launch the browser because you are using a Docker driver. Um. Oh, okay. Sorry. I guess I was reading too far down. Um. That's weird. Oh, it opened my browser. It's just the browser didn't come to the forefront. Okay. So yeah, this is working fine. Right. So what I want to do now is hold on. Let me get back my to do right. Right. So to achieve this, I want to how does this change? So I want to create a Kubernetes job, right? I want to create a Kubernetes job to um right that runs my image, right? Then so I'm going to so one thing I'm going to do is I'm going to grant the container a one vCPU resource limit. Right. Next, I'll do this first. So first thing, let me create the job. Oops, I hit my mic. All right. Uh, so creating the job, I know there's a command, but I'm going to use ChatGPT for this because I don't want to scroll through. Um, I don't want to scroll through like yeah, basically check the internet. So I'm just gonna say a what is the kubectl command to create a job in Kubernetes, right, from an existing image. Oops, submit. Right. Yeah, so this is why I say it's long because I need to be reading this out. So it's like to create a job in Kubernetes from an blah blah blah, you can use the following command. Right. Yeah, I guess it was going to be this straightforward. I just wanted to be sure. I guess the next question is how do I specify the CPU resource? I'm sorry, like the I guess I'll do the requested CPU limits. Yeah, this is what I wanted to confirm. Yeah, so I think I will need to create a YAML file because so that's why I was like, yeah, just doing that probably wouldn't work exactly. So yeah, so I'll create a YAML file for this, right? And I'm just going to create that inside the no, not here, the top level directory. I'll call this job.yaml to share, right? um, all right, cool. Yeah, then I can create this with that, blah blah blah. Thank you. So I'm just going to copy this. Um, I keep saying this on my live chat, right? Don't just copy stuff blindly, and especially like you need to test. Oops, what did I do? Oh, copy. What did I do? That's weird. Yeah, copy, paste. Yeah, so don't just copy things blindly. You'll need to yeah, so here it's saying API version this name. So the name of the job, I'm just going to say my job because why not? Now the things we need here is the image, which is the one we just created. Although I think we'll still need to upload this. Anyways, I'm just going to call this the name. I'm sorry. Oops, that's what I needed. We call this CPU limits, right? Yeah, that's the name of the container. So this is what I was saying. So we're going to request. I want to just request the same, like request one CPU, right? And then I want to see how this would play out, right? Um, so to run this would be. I think I did a poll on this sometime. Was it last year or 2 years ago? On what do you call kubectl? Do you call it kubectl? Do you call it kube control? Do you call it cube? I know there's and cube cuttle that most people call it like cube control. At least from the Twitter poll. So if you call it something else, or if you would call it something else, put it in the chat. Let's see. Okay, so cube control. I actually call it cube cuttle. That's the weird thing. But anyway, the file job.yaml. I think this is going to fail, right? Because actually does Docker desktop show a good view on let me see. No, not Minikube itself. Does Minikube have a good UI? Let's check. I think it should have an easy way to manage the cluster, right? Let me see. Oh yeah, so this is where we can configure the memory and CPU, which I think is we would still need to do that. Yeah, it should have a dashboard, right? Yeah, yeah. So I think I should be able to do like Minikube dashboard. All right, so Minikube add-on, blah blah blah. All right. Yeah. So this is why. So I can easily check the job for this, right? So it says this is failing. Um, the job I just created is failing. Why is it failing? It's creating this pod, and I need. Yeah. So this is the problem. I still need to upload the image because it can't pull this down, right? Um, can I create a new? Yeah, I can. All right. So what I'm going to do is, I think there's like Docker push, right? And I'm just going to do this. Although I think I need to, yeah, I need to. Okay, I know what. I need to rebuild. Yeah, I need to rebuild the image and give it my Docker prefix, right? Cool. So now I can do Docker push. Just going to copy this, paste this here. Right. I think I'm authenticated. So if I'm authenticated, yeah. So this should push to my repository, like public repository. So feel free to download this, whatever. So then I need to update the image here, right? Um, Thanks to everyone that just joined, or anyone that just joined. So I'm basically exploring some things with Rust and Kubernetes CPU resource usage, and so I'm trying to kind of get a view into what do containers see based on the node and the what's the resource specified here. So I'm going to try and deploy this again with sorry, that's kubectl now, right? Oh yeah. So the thing with jobs is um the thing with jobs is I think they are immutable. So like a job needs to kind of run to completion or you kind of get rid of it. You can't like it's not like I think deployments and things like services where they are kind of managed, they are more managed. For a job, you need to do things like a cron job or one other thing. So what I would do for now is I will delete this. Oh wait, can it delete? I don't think it can, right? Hold on. Oh, it did. Because I know I saw a command. So then I can try and like recreate the job, right? And it should come back here. I mean, it's still blue, but let's just check the pod. The pod is green. Wait, it should be done, right? Okay, I put a 10 seconds, but yeah, so it's initialized. Okay, the pod was scheduled, the containers were completed, initialized true, status completed, right? Oh no, wait, is this for the job or for the node? It's very confusing. But yeah, so I think it's completed. So that means it ran to completion, which is good. Is there, yeah, can I view the logs? Yeah. All right. So this is interesting. So here it's saying the number of available CPUs is one, right? So a bunch of things don't add up here because it's saying available CPUs one. The Minikube, the old Kubernetes Minikube environment is running with two CPUs, and the actual my Docker environment where everything is running has five CPUs. So I'm assuming this one CPU is because I specified a one CPU limit here. So what I'm going to do is I'm going to try and bump this up to two. The problem with this is the fact that um I mean if the node is running on two CPUs and I request for two CPUs, it might not end up scheduling this particular um like pod, but then I'll just try it and see. Right. Off. Um, I think there's a way to automatically hold on, let me go back to ChatGPT, right? Um Actually no. I'll manually clean it up. I wanted to say, can I just run it with something that will automatically clean it up, but then I will lose my logs. And so I won't do that. Instead, I will manually just delete. Yeah, I'll manually delete this. Yeah, so this was what confused me the last time because I was like, should I run the command? But it will run it, right? And that should be fine. So I will recreate the job now and we'll check the logs again, right? it's still running, but so now it says two. Okay, so this answers one of my questions, right? So it's saying does um how does this show up, right? So one thing I've noticed from this is depending on the resource. Okay, well, this is not fully answered yet, right? Um, oops. So an answer to this. Hold on, let me just document this here. So here we use the norm CPU's crate because it was easier, right? Right. And and for this second one here, so it appears it is using the CPU. It's basically using these values here, right? The CPU requests and limits resource, the resource.cpu, sorry, report.limits. Actually, so this is interesting because hold on. I think I know the answer to this. I think it's definitely it's most actually, yeah, this is going to be a little bit tricky because in a real life scenario, right, the way these things will be scheduled will depend on what node it's running in. But I think it's most likely using the limits for this. And so the way I'm going to try and do this is I'll request for one and limit to two, right, and see how this will run before I confirm this value here, right? So we'll repeat this. Actually, you know what I should do? I'll use commands to delete this, right? Kubectl, I think jobs. Oh, sorry. Delete jobs. What's the name of the job again? My job, right? Yeah, so I don't have to be going to the UI all the time. And now I can go back to the pod, which is this, and check. Okay, so it still says two. And that is because, like I mentioned, it's using the limits. I entered that, right? I, I guess I mean if you are new to Kubernetes, you based on what limits and kind of like the requests do, it makes sense for the limits to be exposed to like to anyone trying to query for that information from like the operating system, right? So it's using the resource limits. Cool. Now the tricky parts, or what I want to figure out really is what happens if I request for one. Sorry, if I request for like half of a VCP, right? Or let me do this as this, right? So let's say I request for this. What does it show? Does it just round it off to one? Does it stay zero or not? Right? And so I delete the previous job, we run the job again, check the dashboard. The new guy is running. So it just shows one. Okay, one. So even though I specified something lower than one, it shows one. Hmm. I hope. Hmm. I hope this is the same behavior outside of Minikube. But then it makes sense because actually maybe not because now that I'm thinking about it, we should actually look at this code, right? I'm using this num CPU crate, right? And it's just get. Technically, you can't have half of a CPU. The concept of the whole virtual CPU is what allows for like CPU cycles and the time for that, right? And so I'm assuming this get is returning. Actually, let's check the crate num CPUs. Actually, I don't need the crate. I actually need this, right? So what does get return? Mm, Oh yeah, so yeah, it returns a usize, right, which is like a standard unsized integer, right? So this will return at least one. Well, I guess it's good to read documentation, right? For the physical cores, what does that say? Yeah, it would always return at least one. Hmm. Yeah, it makes sense. I feel it makes sense to return at least one. Um, yeah, I mean, it makes sense for it to return at least one. Which I guess for context, for those who didn't join earlier, I'm kind of thinking in context of a project I'm working on where we are allowing people to run code, right? And it's kind of we are trying to, depending on like what you pay for or how large you are, we are giving you instances of this. I'm sorry, we are basically running your jobs as well, your code in a pod, the same kind of pod system, right? So that actually gives me another question, because what if this is more than like what if this is more than one CPU, right? Actually, I guess I can get rid of this. Does it just round it off to two as well? Or is it still one? So let's try this. Right. Where's the oh here, right? So we can check again and see. Oh, so it rounds it up to two. Hmm. Now I feel like going deeper into this to kind of understand how the whole scheduling thing works. Right. Hmm. But yeah, this I mean this is good for me as well, because yeah, depending on the resource, depending on how much resource we give each project's instance, um, if they want to try and do things in parallel, will they be able to? I guess if they ask for, okay. Anyways, that brings me to my third question, which is, can I run multiple threads in a less than one vCPU successfully? Right. Um, this Well, I mean, I'll test this for 500M, right? I'll test this for 500M, and let me just check the chat in case I'm missing anything. Okay, cool. So I'll test this for 500, like 500 milli units, whatever. What's it actually called? But then I assume anything I find out would extrapolate to a 1.5, because yeah, depending on number of cores as well, right? Okay, so it uses the resource limit, right? I'll get rid of my steps here. Right, so the final thing is, can we run this? Can we run two threads um simultaneously, I think, right? And one of the reasons why I mentioned most of the workloads will be kind of like Node.js workload. And the reason why I am using Rust explicitly for this is because things like Node.js, they have a runtime queuing system that can still try and use the single CPU resource on like a single thread. And if I use something like Go as well, it's very hard to control concurrency in Go. Um, so with Rust, I can explicitly, I'm assuming I should have more control in terms of like spinning up threads, at least logical threads, and seeing, are they executing sequentially or are they executing in parallel, right? So going back to, yeah, I'm still going to leave this here. I'll leave this here as well. Um, Actually, I should think through this, but I'm going to use ChatGPT. Oh, sorry, Copilot this time to try and get this right. So I'm going to say create two threads and wait for them to finish this. Oops. Yes. All right. Wait. This. No, I need the full thing. Uh, how do you make Copilot do the full thing? So this, I don't know if Copilot has like commands for these things, right? Um, let's do a quick detour. I will just do a quick detour to see Copilot's docs. So what does it say? Does it say anything around like create unit tests? Um, create an SQL query. Hmm. Doesn't it have like commands for like generating more, or how do you? Oh, okay. So it has these commands. Yeah, keyboard shortcut. Okay, so I can. It says I can do Control Enter to generate. Let me see. What does that mean? Oh, okay. So okay. So yeah, this is what I was looking for. Um, so I said I want two threads and wait for them to finish, which is this, right? Um, although this something is weird about this. Why isn't it like? Okay, it's just the indentation that is a little bit weird, wonky, right? So we run the two threads and then we join. Um, is that what I want? Hold on, I'll just copy this, right? Okay, this is sleep for 10 seconds, right? Um, let me think. So what I want is to confirm, can we run multiple threads on one vCPU or on less than one vCPU? So for this to work, I think the easiest thing I will do is I'm yeah, I'm just going to loop, right? Hmm. Yeah, yeah. I mean, I assume these are like logical threads, right? And like once one takes control of the CPU or whatever, of whatever the logical, yeah, I'm a little bit worried for the actual way it's going to be done. But I assume Ross doesn't do that, so I'm just going to do it in the most straightforward way, where I'll just run a for loop. Um, yeah, I'll run a for loop with a sleep in between, right? So I'm just going to copy this, right? And I'm going to do for yeah. Oh wait, that's weird. Isn't that the same thing I just did? Yeah, but I need 5 here, right? And then I'm going to do the same thing here, right? And I'm going to call this thread 2, right? So there's thread 1 and thread 2. Ideally they should run I can close this now. Ideally they should run well, in parallel, right? And so to test that out, I'm going to actually, this might be too long to wait. Okay, maybe not. I mean, when I run it first time. So I'm going to do like 200 two CPUs for now. Yeah, I'm going to do two CPUs for now. And um yeah, then I'm going to rerun the job. Okay, no, at first I need to rebuild the image and all the other stuff. So readme, sorry, Docker file, right? Build. Yeah. Rebuild the image for me, please. Thank you. So after rebuilding, I need to Docker push the image back up. Yeah. Okay. So I've pushed the new image now, and I can, yeah, then recreate the jobs. So that will be delete the old job, then recreate the job. So we can check the UI now. For the pods, the latest one. Right. So two CPUs, correct, but nothing else. Interesting. Um. Yeah, this is really interesting. Okay, so maybe it's not using. Ah, okay. I think I know why. The reason why it's probably is still using the old image is because so like Kubernetes, it caches the image, and so instead of like pulling from the internet, it's just using the same exact thing, right? Which is good because like standard practice really is you shouldn't be using latest stuff, right? And so instead of I think there are two ways to do this, right? I could push a new one with a different tag, not latest, and like that would pull. But I there's a way you can force it to always pull the image, right? So actually, let's ask what's it called? This guy. Um, what if I want it to always pull the image? Oh, right. I I really love the way like if you don't give like chat well GPT, if you don't give it explicit instructions or you don't tune the parameters to if you don't tune the parameters to always to give you like a short succinct answer, right? Or you don't tell it that hey just give me a short answer, it kind of tries to describe kind of like I know too much, here's more, here's more, here's more, right? And so it keeps going, keeps going, keeps going. I think there's this temperature as well to kind of figure out, yeah, control randomness. That might help. But anyways, the short answer is the image pool policy, and you can well specifying that to always would mean that it's always pulling the image, right? So I'm just going to put that here, and I can delete the old job, run the new job, and I believe now the new pod should pull the new image for this or not. Actually, let me go. Yeah, there's only one container here, so let me go back. Yeah, this was created 20 seconds ago. Container ready. Hmm. Yeah, I mean, it successfully pulled the image. Hmm. So I guess maybe something is wrong with the image then. Did I mean after making these changes? Actually, wait. Why? I mean, the best thing would be to like just run this locally. Of course, there's an error. Oh, I guess I didn't look at the output of the build. Hmm. Where's that log? Okay. So there's actually an error, and it's because the argument is never used. What argument? Oh yeah, that's my mistake. Actually, I think I would use the argument actually just to know how soon it will end, right? Um, and now yeah, so hmm. Yeah, but so I mean, obviously on my PC we have like 10 CPUs, so this can be split across as many CPUs or as many threads as possible. But ideally, if this is kind of what I'm looking for, where one and two are interwoven, right? But in a case where there's probably only one CPU, actually thread.sleep it might be the wrongest thing to do here because thread.sleep. Anyways, we'll test it out. So, but I think this works now, so I can rebuild the image, right? Okay, that worked now. And then I push the new one. Okay. Oh, of course, that was why the previous push was fast. Okay. Now, okay, so I can oh, actually not, it's cube tool. Delete the old job. Uh no, create the new job. Yeah, exactly. So this is like this even starts with like two, right? Which is fine, which is cool. Now I'm going to confirm my theory. I'm actually going to just run on one first, right? Like if there's one CPU, is it predictable? Then I'll try less than one as well, which should also still be sequential. So yeah, delete the job and then create the new job, and we can check the new pods. Hmm. Okay, this is interesting, and I think it's so like one, right, one, then two, three, and I think I know why, which is why I said this probably is not going to work, and the reason is because of this thread.sleep. So I mean, thread.sleep is basically saying it's basically saying, hey, I'm suspending this thread for a couple of minutes. And so the CPU can definitely cycle onto the next work, which is this, right? And that is not what I want. That's not what I want, right? I actually want them to run like parallel, right? Be like on multiple cores as well. So what's the easiest way to do this? Hmm. I guess one easy way is I need to run something that is slow, right? Yeah, I need to run something that is slow inside this loop, right? Um, so let me try asking Copilot. No, actually GPT, because actually I don't know. Maybe Copilot, because I would like something that would like give me the full context around what crate to add. Um, so I'm going to, I guess if I reload this page, it should reset everything, right? Okay. So I'm going to say I need to generate a slow. I need, okay. I think a better way would be um I need to artificially generate a slow running computation. Let's see how GPT-4 is fast. A slow running computation in Rust. Is is there a standard function or crate that I can use for this? Right. Let's see. Thanks to everyone that has joined so far. There isn't a standard function specifically for generating slow computation. Yeah, I don't want to use sleep. right? Yeah, I should have told it to be succinct anyways. And the reason is if you so docs rs thread sleep, right? Yeah, this. So it puts the current thread to sleep for at least the specified amount of time. The thread may sleep longer, which is fine due to scheduling specifics. It will never sleep less. So, I mean, this is what I'm saying because it's schedules to a new. So it basically says sleep, right? And then looks for other like pending thread tasks to run. And that is why, even for one CPU, we still have them interleaving because when this sleeps, right, it picks up the second thread and well, depending on how fast like the next one can resume, and that's why this resumed. But it's very unpredictable. It's kind of like what threads do, right? And so I don't want sleep. I want I want like some random number generator or something. If you need more complex binary control about the delay, no, not that. So I'm gonna say I don't want to sleep. I want a computation to run. I want maybe like a function that runs a computation for a few seconds. I don't need um I don't need control over how long the compute. I don't need precise. I don't need precise control over how long the computation runs. I just need it to run for a few seconds. Right. I'm assuming Google should get this running. Okay, so you're saying I should use time. While instance noun perform some computation. Uh, I mean, this actually isn't bad, honestly. Yeah. Um, I mean, the solution here isn't bad because what it's recommending here is like for let's say a specific for a specific like 5 seconds, right? Yeah, for 5 seconds rather, right? Just run this randomly. Um, I will keep running this, which is kind of what I want. So I'm going to copy this function and use this for now. Um, copy this, right? Because at least with this, it keeps running the loop. I don't know why I thought of some cryptographic running function. Um, but at least with this, it will keep running. Yeah, it will keep running this loop for the duration, right? Oh, can I nest this? Oh, but then it's okay. Yeah, then I can do self. Thanks, Copilot. Yeah, because but then the problem here is I'm using time somewhere else, aren't I? Yeah, here. So I don't need time anymore here. Oh, I mean, if I do self, that will import time as well. So, anyways, it's fine. Um, then I can get rid of this and maybe this. I'm just going to leave the comments here because I plan to push this to Git at one point. And so anyone can read the comments if you don't understand Rust, right? Then for high in this, hello from thread one. Then Then I call slow computation, right? And here as well, I call slow computation. However, so I don't have to wait for so long. This would probably just be like a 2 second slow computation, right? 2 times 5, 10. Yeah, that should be fine. Right. So I'm going to do cargo run this, right? And to test my hypothesis, right? Yeah, so now you notice it's a little bit more predictable. And the reason why it's more predictable is because if they are both running in parallel, right? And I'm not using thread.sleep, which means it's not like letting go of the operation and giving to the scheduler, then this should work. Then they should work in a predictable manner. So every 1 second, 2 second, and that explains why. So you can see like it's one, two, one, two, one, two, almost at the same time, like they show up at the same time, right? This is what I want. Now, if we had only a single CPU, then I'm assuming the second thread shouldn't be scheduled while the first thread completes his work. Yeah. All right. So, okay, following the same steps, right? Publish, build the new image. I probably should just do this with. um, yeah, I think that was successful, right? So new image builds, push the new image, right? Then I will, oops, delete the whole job, create the new job. Now let's check the logs. Let's see what the logs say. Wrong logs. Pods. This is the latest pod. Hmm. Okay, is so I guess it means the threads what's it the threads were the threads were scheduled onto the same CPU as well. Um this is actually interesting, and this is why I'm actually doing this to kind of get some better understanding on how the whole thread scheduling works. I feel Rust should give me close to metal kind of implementation, and that's why I'm using it. I mean, I can probably peel back the layers and focus on like a Linux environment or something, right? Um, so this is same thing. I'm going to try what happens if I reduce this, right? Like let's just say I reduce the request and the limits. I know it will still say, oh, okay. It will say one CPU, but yeah, I want to see how this would work. Um, so delete the job, create the new job, check the pods. Yeah, this is the new one. Okay, this is a little bit, this is even more weird, right? Because, oh, okay, maybe I need to auto refresh. Yeah. Yeah, this is even more weird because now we are seeing hello from thread one, right? The one and two, but two works before this, right? Which is even more interesting, and which means that probably what I'm thinking isn't as working as expected, right? Which I think is fine. Um, because yeah, this is why concurrency is hard, right? um, one thing that came to mind is so I'm working on an article to kind of explain how this CPU yeah, like how this whole requests and limits thing, how they are calculated or how they work. And it will also kind of help me answer these questions more. But um, technically, I think Kubernetes itself can impose limitations, right? So let's say um, your 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 program is running requesting CPU time, right? But then when Kubernetes realizes, oh, your program is using this amount of CPU, right? It kind of does a thread.sleep, right, on your program, and then when there's enough like recycle, it's when there's enough like time, right? Actually, um there should be, let me do Kubernetes CPU limits diagram or something, right? Mm, can we find a, no, not this. I remember seeing, yeah, this throttling. I don't know if this is the exact article. Yeah. So yeah, exactly. So this is, I was basically looking for something like this, right? And so when you specify a particular limit, right? It's basically saying that so okay, so like see, so now consider an application with a CPU limit of zero point 0.4 CPU. The application will only receive about 40 ms of runtime for each 100 ms, right? So which means for every 100 milliseconds, right, it gives your application 40 milliseconds, right? There's a way to calculate this whole stuff. So what that means is, in our case where we are like running a competition for 2 seconds, right? In the middle of that computation for 2 seconds, it is going to pause, right? It's going to pause after 40 ms, which is kind of like a thread dot sleep, but not really sleeping for a duration. It's sleeping for like the throttling period, and then it gives back control to your application. And so what that means is your application, well, not your application really, but the way the scheduling, the tasks are kind of scheduled, right, in terms of the threads. And so basically the scheduler is like, oh yeah, the second thread is waiting as well, right? So chances are it might pick the second thread up to continue its work. And that's why concurrency is hard, right? Um, but yeah, so I think that might also be what is happening here, um, which kind of defeats the point of this. I mean, not necessarily defeats the point. It kind of answers my question, right? It says, can I run multi-threaded in less than one vCPU successfully? And the answer is yes. Yes, because, right? Because of CPU throttling. Because of CPU throttling, right? Yeah, because of CPU throttling, really. I'll when I'm writing my blog post, I would think of a better way to kind of describe this. But yeah, I think this would be a good place to end this for now. Um, kind of answers the question, and um, so it kind of answers the well. I mean, now I can kind of think around people that for the project, right? I can kind of think around, oh, what does it mean for us to provision a larger instance for you, and what can you do? So it means that, oh yeah, definitely you can run parallel jobs in your particular code instance, and yeah, and you technically, yeah, and so I think that is what really matters, right? From a Kubernetes standpoint, what really matters is not really, because is vCPUs, which are like virtual CPUs in the sense, and CPUs themselves are more of like cycles, right? So your one CPU has a 2.7 gigahertz CPU cycle, right? Basically what that means is like, 2.7 gigahertz process per seconds per process. Anyways, um, yeah, process per second. Confusing, but anyways, so it's like, oh, splitting that up into like virtual cores and splitting the whole processing time across different threads, tasks, right? And so yeah, I think this might also shape the kind of article I want to write as well, which is that. Um, but yeah, I think at this point I should stop the call. This is what this has been good. Um, if you Thanks to everyone that joined and those that are still here till now. Um, I'll catch you guys on the next one, and